हाँ बच्चों, we were discussing the transportation problem. In continuation with the transportation problem, today we are going to discuss the unbalanced problem. This is important one. Let me have one problem related to that one. It is unbalanced in nature. What is unbalanced? Means demand and supply, it is not getting matched. So I am taking one problem related to that one. So let us have, there are 3 origins and 5 destinations. There are 3 origins and 5 destinations. Look at the problem. There are 3 origins. So far it is given origin are 3, O1, O2, O3, and destinations are 5, 1, 2, 3, 4, 5 destination. This is given to us. Destination D1, D2, D3, D4 and D5. This is given to us. And the cost matrix related to that one is 3, 5, 8, 9, 11. This is the cost matrix which is given to us. Another one is 5, 4, 10, 7, 10. This is the cost matrix. It could be in rupees, it could be dollars, it could be any other currency. 2, 3, 8, 7, 7. So basically, this is the problem related to this one. Now, come to the main point, the availability. The availability. For the origin O1, the availability is 20, 40, 30. 20, 40, 30. If you count it, the availability is 90. And what is the demand? What is the demand? Look at the demand. This is 10, destination D1 having demand 10 units, this is 15 units, D2 is 15, this is 25. What is the value? 40 plus 50? 50, and this is D4 is 30 and D5 is 40. If you count is 40 plus 30, 70, 70 plus 40, 110 plus this is 120. This is called unbalanced problem. This is called unbalanced. This is 50, 30, 80 plus. This is unbalanced problem. Means what to do here in this case? First of all, make it a balanced problem. Otherwise, you can't solve the problem. Means we'll have one more origin. Means the availability is instead of 90, it should be the 120. And how to solve it? Please look at very carefully. I have introduced the word dummy. Dummy row. Origin O1, O2, O3. And this is the dummy. I have introduced the dummy origin. This is D2, this is D2, D1, D2, D3, this is D4, this is D5. Now, again this is 20, this is 40, this is 30. If you count it, this is 60 plus 30, 90 plus 30, 120. Again this is 120. Now, here it is 10, this is 15, this is 25, this is 30, this is 40. Clear? Now, this is 3, 5, 8, 9, 11, this is 5, 4, 10, 7, 10. This is 2, 3, 8, 7, 7. In dummy, you are taking the cost to be 0, means presently we don't have any cost which is being consumed here. Okay, this is the minimum cost which is consumed here. Now, this is also 120. Now, availability is 120. By introducing y additional row, similarly, demand is also 120. Now I can proceed further. Now I know there are 5 rules to calculate the initial basic feasible solution. But presently I will go with the VAM, that is called the Vogel's approximation method. Why? Because there is a probability of getting the optimal result in the very first iteration. So we will go with the VAM method. What is the VAM method? Take the difference, minimum, take the difference of minimum 2 values, least value 3 and 5, this is 2 here, go to the this one, second, this is the second row, the minimum value 4 and 5, difference is 1, go to the third row, the difference is 1, 2 and 3, go to the fourth, the least values are 0, 0, difference is 0. Go to this one, the difference is 2, 0 and 2, this is 0 and 3, this is 3, this is 0 and 8, the difference is 8. Here it is 0 and 7, the difference is 7. Here it is 0 and 7, the difference is 7. So choose the most, means the highest difference, that is the 8 here. Choose the least value, the maximum allocation which can be made either 25 or 30. Here it is 5. This has been cancelled out. This will remain as it is. This is 2, first column, the second column 3, third column has been exhausted. Go to the fourth column, this is 7, this is also 7. Is it okay so far? On this side, row side, let us here, again the difference is 2, again the difference is 1, the least cost are 5 and 4, here the least cost 2 and 3, this is 1, the difference is 0, 0, this is 0. And out of that one, choose any one of randomly. Let us assume I have chosen the fourth column. The least cost is 0, the maximum allocation which can be made is 5 or 30, the value is 5. So this has been exhausted. This has been exhausted. And if you look at here, this will remain same. This is 2, difference is 2 because the column this has been exhausted. So there is no change in the row. This is 1 and here it is 1. Clear so far? Look at here. The difference is 2 and 3. The difference is 1. Here it is 3 and 4. The difference is 1. And here it is, the difference is 0, 7, 0, 7, 7, twice it is there, the difference is 0. This is 7 and 10, the difference is 3. Pick the most positive value or the difference of that one, that value 3 is chosen. And pick the least cost, this is 7, here it is 30 and 40. This is 30, this is 10, this has been exhausted. This has been exhausted. This will remain same. This is 2, this is 2, this is 1. Is it okay so far? Now here it is, look at here. This is 2, this is 1, this is 2, this is 1, again this is 2, this is 1. Now there are a couple of times where we are getting the 2, the highest value is 2. I take this 2 here, the minimum value is 3, where the allocation can be made. Maximum allocation can be made 10, this is 0, this is 10. So this has been exhausted. Again calculate, this is 1, this is 2, difference, again this is 1. On this side, look at here, the difference is 5 and 9, the difference is 4, clear, and the difference is 3. The value 4 has been chosen, because the highest difference will be taken that one. Choose the least cost on that row, the value is 5. The maximum allocation which can be made 10 or 15. So 10 has been made. So this row has been exhausted. So we are left with now here it is, if I made the allocation here, because there is difference, there is no difference now, 4, 7, 10, start with this one, this is 5 is here, this is 0 here, this is 35, clear? So this has been exhausted, this column. Now here it is 25, this value is 0 and we are left with 10. So this column has been exhausted. This is 10, 0, 0. Now calculate the total cost. Now calculate the total cost. When you are calculating the TC, look at the TC. This is 3 into 10 plus 5 into 10 plus 4 into 5 plus 7 into 25 plus 10 into 10 plus 7 into 30 plus 0 into 25 plus 0 into 5. When you are going to calculate, this is 30 plus 50 plus 20. This is 175. This is 175. If you look at here, 25 into 7, this is 125 plus 100 plus 210 plus 0 plus 0. When you count it, this is 80, 100, 100, 100 plus 175 plus 310. This is 310. If I count it, 5, this is 8, this is 5. This is the cost, 585. This is the cost. It could be in any currency, Indian currency or as well as in a US currency, means dollar. So whether this solution is the optimal one or not, for that we need to perform the optimality test. Let us perform the optimality test. Let us perform. For optimality test, we are making use of the Modi method. We are going to make use of the Modi method. We are left with 585. This is the cost. Let us perform the Modi method. I rub it here. This is the cost which is associated here, 585. Let us start with that one. Again, we know there are two conditions which has to be met. All allocation must be in independent position. The second is actual number is required number. This is 1, 2, 3, 4, 5, 6, 7, 8. The actual is 8. What is the required? We know the formula, m plus n minus 1. The number of rows are 4. The number of columns are 5. This is 8 is equal to 8. Means it satisfies this one. We can go ahead with the Modi test. We are going to perform the modified distribution. First of all, make a cost matrix for allocated cell. Let us make a cost matrix for allocated cell. This is 4 by 5 matrix. This is 3. This is 5. This is 4. This is 7. This is 10. This is 7. Here it is 0. Here it is 0. 3, 5, 4, 7, 10, 7, twice 0. This is the cost matrix. Then UI Vj matrix. Then we are going to calculate UI Vj matrix. If you recall, this has already been UI. This is U1, U2, U3, U4, U5. Vj matrix. This is V1, V2, V3, V4. Either of take 0. UI Vj matrix for allocated files. This is 0 here. This is 3 here. This is 3. This is 2. This is 2 plus 2. This is 4. 2 plus 5 is 7. 2 plus 8 is 10. 8 minus 1. 8 minus 1. This is 5. This is minus 5 to make 0. This is minus 5. This is plus 5. Is it okay so far? Then again make a matrix. Again make a matrix. UI Vj matrix for non-allocated cell. UI Vj matrix for non-allocated cell. Look at here. 1, 2, 3, 4. Here the allocations have already been made. So look at here. The allocation. Here if I count it, this is 8 here. This is also 8. This is 11. This is 11. And here it is 2, sum of this one. This is 2 plus 5, this is 7 here. Is it okay? This is minus 1. This is 1. Here it is 4, here it is 4. Here it is minus 5. Here it is minus 3. Here it is 3. Now make a cell evaluation matrix. Now this cell evaluation matrix decide whether the solution obtained is the optimal one or not. We are going to calculate the cell evaluation matrix. Put a hyphen, there the allocation have already been made. Okay. So this has to be subtracted. This is 8 minus 8, this is 0. Then 9 minus 8, this is 1. This is 11 minus 11, this is 0. This is 5 minus 2, this is 3. This is 10 minus 7, this is 3. This is another one. Here if you look at here, this is 5, this is 5 minus 2, this is 7, 10 minus this. Now go to here, this is 2 minus minus, this is plus. Then 3 minus 1, 3 minus 1, this is 2. Then 8 minus 4 is 4. Then 7 minus 4 is 3. Here it is plus, because there is no allocation, this is 0 here. Here it is plus 3, and here it is minus 3. So the solution obtained is not the optimal one. Look at here. Again do the iteration. This is called iteration. This is plus, this is minus, this is plus, this is minus. So this minus, this minus. When you look at this minus, this is 5, this is 10. This is 5, this is 10. Choose the least one. Here it is 5. 10 minus 5 is 5. Here it is 5. Here it is, you will leave it as it is, this is 30. Here it is 30, 5, 25 plus, this is 0. So this is 0 here. So you will keep as it is rest of the one. Here it is 25, here it is 25, here it is 5, here it is 10, and here it is 10. Look at here. This is 10 plus 10, this is 20. This match with here, this is 40, this is 30, this is also 30, this is 30, this is also 30. So here it is 10, here it is 15, here it is 25, here it is 30, here it is 40. So calculate the total cost. Let us calculate the total cost. When again we are calculating 3 into 10 plus 5 into 10 plus 4 into 5, 4 into 5 plus 7 into 30 plus 10 into 5 plus 7 into 30 plus 0 into 25 plus 0 into 5. Look at here. This is 30, this is 30, this is 50, this is 50, this is 20, this is 210, this is 50, and this is 210. Look at here. Whether the cost has been reduced or not, this is 100 plus 210 plus 260. This is 0 here, this is 7, this is 570. Earlier the cost was 585. Now the cost is 570. Now again this cost has been reduced. Now again we can perform the same MODI test. So repeat the same procedure till we get all the cell evaluation to be positive or 0. So most probably once we do the same iteration what has been discussed earlier, we will get the optimal cost. So that's it from my side. If you have any question you may ask. The more important is this is the unbalanced problem. Here availability and demand are unequal nature. Thank you very much.